Now we're ready to go. All right, y'all. Thanks so
Okay,
much for
we'll
all
be
your
off
help.
camera, but we will be here if anybody has any questions.
Yep, they'll be in chat hanging out with us as well. They'll be with us in spirit and in the Discord chat as well, which I think is pretty fantastic. So welcome to getting started with BHIS, MSP, and SOC. I just lost my screen sharing tray. There we go. Now we got it. So I want to say first, thank you very much for coming. This is the first in our series of pay what you can classes that I provide. And we have a number of other ones from people like Kevin Johnson and stuff, which are fantastic. You should check those out too. But we do a lot of the pay what you can classes specifically for the core skills that people need to be successful at their jobs. And I think we had, Megan, correct me if I'm wrong, 250 people registered for this one. Do I trust this computer? Sure. I trust this computer. No, 178. That's
Yeah,
great.
sorry, couldn't find my mute. My
No, we're
bad.
good. We're good. 178. So we got a good number of people that are hanging out. We're also going to have people joining on YouTube, I believe, as well. We have our stream available there, and I think it's on LinkedIn. So we're all over the place trying to help people develop the core skills that they need to be successful at computer security. It is also in conjunction with the cyber call. Andrew Morgan and that crew. Trying to help level up the MSPs and the MSSPs in the community is another huge part of what we are focusing on in this class. And the reason for that is something like 60% of the United States critical infrastructure is protected by small security teams. And sometimes they're not even security teams. They're just MSPs that have security stacked on top of literally everything else that they are doing. And this is a huge shout out and respect there. If you have came in here and you're with an MSP or an MSSP, please type in MSP or MSSP in the Discord server. Let's get those muscles going. We got Epsilon is here. Of course, Epsilon has been around for a while. And be sure to check out the Cybercall podcast, which is fantastic as well. All right. So what are we going to be covering in this particular class, right? When we're looking at a lot of classes that try to get you started in computer security, including a couple of my courses as well, they jump you in very quickly, and they have a lot of assumptions that you understand core security or core technology concepts, right? Like intro to Windows, intro to Linux, TCP/IP, basics and fundamentals. And all of these things are kind of the core things that are needed to work at SOC, at Black Hills Information Security. And Grumpy Cat says, how about no? But actually, Grumpy Cat, we are going to be covering those topics in this particular course because those topics are so incredibly fundamental to understanding what is going on whenever you're working in a security operations center or any part of computer security. This class eventually leads into the intro security class as well. Now, another quick note whenever we're discussing Grumpy Cat and kind of making Grumpy Cat sad. These things are also really important whenever we're talking about artificial intelligence. As much as I can throughout this entire course, I am going to be discussing how we can utilize the skills that we have here to become better users of the tool that we call AI. Unfortunately, a lot of people think that AI is just going to come in and automatically replace a bunch of basic level skills and it's going to do all these things for us. And not yet. Maybe someday, but that day is not today. If you're looking at artificial intelligence and how we utilize it effectively, it becomes incredibly important to understand that AI is a tool. And AI, whenever you're using it as a tool, is very context dependent. How do we actually train or tell AI to do something that is, useful for us instead of actually ending all humanity? Or, as many people are trying to use AI today, trying to sell us more advertisements. That always blows my mind, right? Look at all this investment in AI and people are like, well, AI is going to be heavily used by Facebook. It's going to be heavily used by Google. They're going to be using it for all of these things. And I'm like, ads. You're going to try to get AI to sell us more ads. And that's sad. And I don't know if I need any more ads. However, AI being used in a security operations center is absolutely something that you're going to encounter. It absolutely is going to be something that you're going to be utilizing consistently in incident response, penetration testing, in all aspects of computer security. But It is a tool. And the better the data that we can feed into that tool, the better the outcomes we will get from that tool. And this class is all about understanding the core fundamentals so that whenever you're talking to AI or programming or trying to set things up for different agents and different things like N8N and trying to set up workflows, that they'll actually make sense and AI will have the appropriate context to be able to do what you need it to do. So it becomes essential for that as well. Now, there is a little bit of overlap in this course with other courses. It is naturally something that is just going to occur. And in this class, we are going to have a little bit of overlap with the intro to security. The information security core skills classes. I think the other one that we have after this, we had to change the name because we didn't piss off SANS directly. But SANS on LinkedIn was like, hey, we already have a security fundamentals class. I was trying to stay away from the security essentials because I knew that that was security 401. I didn't know that there was a security fundamentals class, but there is. So we had to change that name. They asked very politely without a lawyer involved, and we tend to react better to those situations. So that class that comes up after this one is, what is it? Fundamentals of, no, it's not a fundamentals, core skills of information security. The name is awful, but that is what the name is. It sucks. Yeah, we better call Saul, right? You know, if I need someone, you don't need a criminal attorney. You need a criminal attorney. Maybe that's what we need, right? But there is definitely overlap. And then it also feeds into my next or my final pay what you can class in the overall cycle, cyber deception. Kind of like Decepticons, but without the robots. Unfortunately, there's no Transformers in that class as well. All right, so this also feeds into getting a lot of the core fundamentals that we need out of the way as it relates to my 5-year plan. I have a lot of people that are university students that want to get into computer security. Super excited about getting into the industry and doing things in the industry. And I did a webcast on this, the 5-year plan, that talks about if you're in school, if you're in high school, if you're in college, or if you're just kind of in between jobs or working at a job that you hate, that you have a lot of free time on your hands at said job that you hate, and you want to get into computer security. How would you go about doing that? And I created a webcast that covered those topics. In fact, a lot of the subjects that we cover in this class are basically years 1 and 2 in that. But for the record, you can do it in 5 years, but you can also do it in like 3 or 4 months if you're completely dedicated to it. It's kind of strange. We've had a number of truckers and people in the trucking industry that have somehow gotten hooked into this course and shared it, and a lot of them do it. And I think that's because they're driving and they're listening to me, and when they're downtime, they're on the computer doing labs. So, you know, go get it, get her done if you're out there trucking. I don't know if you can see this, but I'm doing the honk your horn thing, honk your horn across America for any truckers that are doing that. But we have a number of people that do this and dedicate to this as well and get it done in just a few months. So it's meant for somebody in school and somebody that has a job, but you can absolutely knock it out fairly quickly as well. All right, so how are we developing this class? How are we working this course? Everything in this course is going to be filtered through the lens of you are compromised. What do you do now? So if you believe your company to be compromised in some fashion or another, how do you actually deal with it in the next steps, right? So when we're looking at Linux, we're going to look at Linux through the lens of you've been compromised. When we look at Windows, we're going to look at it through the lens of you have been compromised. And we're going to continue to focus on that kind of mindset through the entire course because it helps create a mental framework and a model for you to kind of latch on to the concept. So let's say that we had another class, let's say it was a longer course. A lot of classes try to pad as much as they possibly can with basically the man pages of tools where they go through all the different options and all the different things that the tools can do. And that's fine. There's absolutely nothing wrong with that from an in-depth perspective. But I have found whenever you're looking at pedagogical methodologies, isn't that a big word, ladies and gentlemen? Bet you didn't see that one coming. But yes, if you're using pedagogicals, and I am a pedagogue, it tends to stick better if you can actually learn something by using and getting your hands dirty and having it applied to an overall narrative. So a lot of our narratives are going to involve malware. When we're looking at network traffic, we're going to involve malware. When we look at Windows, we're going to be involving malware, and that's just how it's going to roll. Now, why are we doing this? Like, why do we look at it this way? One, because negative things, kind of from a mnemonic perspective, tend to stick in our heads a little bit better, right? When we think in terms of bad things that happen, it tends to just eat with us. And that has a lot to do with how human beings are wired. If there's something negative that happens, we tend to remember it. It's like when you get home, if you saw a car wreck, you tend to talk about that because as human beings, we gravitate to those things predominantly from the perspective of a shared narrative and shared kind of denialist propagation, if you will. But when people are working in incident response and they're trying to do IR, first steps are wicked hard, right? If we're coming in the Boston area, if you're looking at these first steps, these initial steps to get started, a lot of people are so afraid of making a mistake that they do the worst thing they can do, nothing. They get paralyzed. And this is generally because, as a rule, human beings suck. If you look at human beings, we tend to judge each other based on our failures, right? If you look at a lot of people in the industry, let's say you do everything right, but you screw up one time, all of a sudden you're up for a promotion, you're up for a raise. People will be like, well, John did everything right this year, and he did a number of good things that we think are fantastic. However, you do remember that one time that he brought down our entire cluster? Yeah, I don't think that John is ready for a promotion yet because of that cluster outage that he did 6 months, 7 months ago. We tend to only judge people on our failures. So when we're working in kind of these types of stressful scenarios like a hack in an organization, we tend to take a step back and not want to move unless we're explicitly told that we can do it, all because we're trying to protect ourselves. So we need to give you the steps to move forward. We keep moving, to have a plan. And we're going to cover some of the basic first steps of things that you need to understand as well. Now, this becomes important also when we're talking about cloud computing, right? If we're looking at cloud computing, especially in the Linux sections, we're talking about the application analysis sections and the networking sections, become critical to understand those because those skills will be applicable not just for hosts, but also for servers as well. And one of the big things that I try to avoid is this. You have a number of classes when they're working on incident response and a number of companies when they're working on their incident response plan, they try to develop very, very complicated IR procedures. And these procedures are step-by-step how to handle every single type of incident that you could possibly think of in your organization. I'll give you a narrative on this. So a long, long time ago in a galaxy far, far, far away, I would say roughly 2005 timeframe, I went to work at Northrop Grumman. I was doing cleared work at the time, and I just got my clearance. I was really excited about it. I was expecting it to be like a movie with really cool lighting and all the people like tone and fit and great skin tone and all of that. And that wasn't what it was. It was basically a dirtier cube farm with sadder people without access to the internet. But at any rate, I was charged to go in on the unclassified name of the program was Intelligence Community Multi-Acquisition Program. That's ICMAP, and was hired to go and work on that program. And I had been teaching for the SANS Institute briefly at that point, the mentor in the community SANS program. And they were like, you know, incident response. And I'm like, well, yes. Yes, I do know incident response. And they're like, great. Well, you can help out with the IR process. And I'm like, this is great. This is what I do. I'm going to nail this. And they took me into this room, which once again had like dirty carpet and like, peeling paint, which I'm sure was lead-based. I didn't taste it to make sure, but I'm pretty sure it was lead-based paint. And in there was this dude named Bill. Right. And Bill is like 98 years old. And as soon as they introduced me to Bill, they're like, yeah, this is Bill. He's been working on the IR procedures. Bill, this is John. Bill looks up at me and is like wheezing. He's like, kill me. I'm like, oh, dear God. Right. And they're like, well, Bill, can you show John the IR process? And Bill reaches under his desk, wheezing the whole time. And he pulls out this like 700-page disaster of an IR plan. And in there was every single top 10 virus or worm that had hit they would have detailed IR instructions on how to deal with that virus or that worm. Every single one of them. So if you had the top 10 this week and all of a sudden there was a new one, let's say number 10 was replaced by a different one. It was like SQL Spida AXB21 variant. Then he would go and create detailed incident response procedures for every single one of those viruses. Now, I got a question. If any of you were working, let's say, any type of incident response at all, right? Like if you were working IR at your organization, what would you do if somebody gave you a document that was like 700 pages of IR steps? Most people, I'm guessing, they would just throw that crap away, right? Read it, right? You know, Penguins of Madagascar. Brick would cry. Don't cry, Brick. Don't you cry tonight. There's a heaven above you, Brick. Yeah, don't cry. Don't do it. I prefer Firestarter. I'm glad that we have Kevin here because Kevin can help me out with the singing as well. You wouldn't read it. This is worthless, right? Like whenever you create detailed incident response procedures that are so complicated and convoluted, they're actually going to contradict themselves. It's just going to be completely problematic for everybody. It's going to suck. So what do I recommend instead? What I recommend instead is this. Lego bricks. See, Brick, I picked you out. I picked you out, Brick, for a reason. Because on the next slide, I was going to talk about bricks. Do you see how that ties? That's foreshadowing. Yep, I'm looking at the future. Got Janice, the future and the past. Brick. All right. So when we're looking at Lego bricks, everything is awesome, right? Now, if you remember in the movie, the first one, which I really liked, the second one was good too, but the first one was amazing, super deep movie. Elliot, I think that's the name of the main character, although I'm not sure. But Elliot, whenever he encountered a problem, he would use the Lego bricks available to him to assemble the tools and the machines that he needed to solve that problem. That's what he would do. And that's the Chicago way. And that's the way you get Capone, because we have tied this into a game called Backdoors and Breaches. I don't know if Tim is available, but we might be able to get you into competitive Backdoors and Breaches. Would you guys like to beta test something for us? Yeah. So we created a game called Backdoors and Breaches. So I'm going to go to play.backdoors and breaches. Backdoors and breaches. Choose the core deck. And we created this incident response tabletop game. And we have these blue cards down here. And these blue cards are designed to help you work through an incident. These are the things that'll help you solve the incident. These cards up above, initial attack and compromise, pivot and escalate, C2, and persistence, are the ways that an attacker would break into your environment. So they would use things like credential stuffing, right? And they would do things like broadcast, multicast protocol poisoning. They would use HTTPS as exfil. They would do malicious firmware to persist on your environment. And for each one of these cards, if you look at the detections, it tells you which one of those cards detects the attack card, right? But the point is, almost any type of attack that I can create, almost any type of compromised kill chain that I put up here is detectable through these like 10 or 12 cards down below. About 10 or 12 cards, right? User entity behavioral analytics. I just lost my, no, come on back, Buffalo. So whenever I teach, I talk to the camera and I put a buffalo on top of the camera. I've got to tape him onto the camera and his tape is coming loose. But let's put the buffalo back up there. Or he's actually, yeah, there we go. There, he's back where he belongs. But we have these blue cards that we can use that'll help us turn over those red cards. And as you can see, every time I hit refresh, I create a brand new kill chain, and that kill chain is still detectable utilizing the blue cards down below. Great white buffalo in Lakota, that's Tatanka Sky. So, all right. So instead of trying to focus your energies on an overall process for incident response, we want you to focus on the blue cards and understanding the concepts of how that blue card actually works. So in this class, we're going to have a lab on log analysis utilizing UEBA and log analysis. We're going to have a lab on network threat hunting. We're going to have a log on memory analysis. We're going to have a log on endpoint analysis. We're going to have a log on server analysis, endpoint analysis. Cyber deception is a completely different class, and firewall log analysis. So we're going to be teaching you all of these different things to basically give you Lego bricks that you can use in the event of an incident to be able to react appropriately to that incident as well. Now, also, whenever we're looking at an incident, one of the things that I keep pushing is the idea of, hey, don't panic. Panicking is bad, okay? It's not a good thing. So how do you prevent somebody from panicking? I've been to a lot of incident response classes over the years, and they say crap like this. It's like, keep calm and keep focused and don't panic. By the way, you know the history of that sign, the one that says don't panic, or says keep calm and carry on in the UK? Does anyone know what the history of that was? It's kind of wild, actually. Keep calm and carry on. I think it was picked up by the Chive, and it was keep calm and chive on, and it took off, and everybody was doing all these things with it. It was not the World War II air raids in London. They were never really put out publicly during World War II. Jesse nailed it. It was an unpublished World War II poster. They had a whole bunch of these posters created. They had these posters created specifically in the event that the United Kingdom lost to Germany, and Germany successfully invaded the United Kingdom. And if that happened, they were going to go through and they were going to put these posters up that said, keep calm and carry on to keep people calm. Worst case scenario happens. That's the history of that poster. But how do you get someone to not freak out? You know, how are we going to get people to not freak out? Well, if you think about it, the best way to get it to the point where you do not freak out is just like Brian said, train. You get to the point where you do something again and again and again to the point where it becomes second nature, almost muscle memory, and that becomes powerful in reducing fear. Right? People tend to be afraid of things that they haven't done before. And then after you get used to doing that thing and doing it again and again and again, you get more comfortable with the idea. I think of this in terms from my life, like mountain biking or surfing, right? When I first started mountain biking, being on a trail this wide was terrifying, right? Trying to keep your balance, not doing it. Now I can go relatively fast. On surfing, we can go through and, you know, the first time you get on a surfboard, you're so afraid, it's very hard to think and surf. After you get used to it, you get that underneath you. You get that expertise on it as well. The question is, how do we utilize these Lego blocks, just like Elliot? So if you're in the middle of an incident and you understand how to do these different components associated with backdoors and breaches, you can assemble these components to match whatever threat actor you're encountering. Does that make sense? Kill mind hacker. You want to get to the point where you can get comfortable with these, and then you can build them to anything that you would encounter on it as well. All right. So we're going to start at the very beginning because it's a very good place to start. And Brian doesn't even have to, he doesn't even have to get me tweaked, by the way. He just doesn't, because I already I'm going to start tweaked when we're talking about networking. This is the only class, Brian, that I have it like built into the agenda. I have it built into the timing. I'm going to start tweaked. We're going to kick it off right here with a rant. And here's my rant. My rant is this: the OSI model, the Open Systems Interconnect model. So my question to those of you that are new here, how many of you have been forced to learn the OSI model? Please do not throw stale pizza away. And you got like, well, we've got the physical layer, we've got the data link layer, we've got this, we've got that, and there's a session layer, and we have all those things. All right. So the 7-layer cake or the 7-layer pie or the 7-layer dip or whatever it is, 7-layer bars are delicious. The ones with like coconut and stuff, they're yummy. They're very good. But the 7 layers of the OSI model are a lie. Packets don't work that way. Networking does not work that way. A lot of people will argue and basically be like, well, it's a good mental model. It's not. It's absolute garbage. We shouldn't be teaching it because it's not how computers work. It's all lies. Now, I know some of you are like, I had a college professor teach me this, and I think he's pretty smart. I am sure this guy that I just found on the random internet, hi, YouTube, is wrong. Stick with me for a couple of moments and I will prove my case. All right. So the first thing I want to share with you is an article from IEEE called OSI, the Internet That Wasn't. And this goes through the history of the OSI model. And it talks about how the OSI model started all the way back in the 60s with these dudes. And I know this looks like it's something straight out of Mad Men, and I'm also completely certain that they are drinking a lot of bourbon and smoking a crap ton of cigarettes, okay? But these are the guys that kind of set up the OSI model. Started in the 60s. This is one of their meetings in 1974 on it as well. But this entire history kind of breaks down how the OSI model was created, how it wasn't really implemented, and how the TCP/IP four-layer model actually won. And the TCP/IP four-layer model is the model that the internet uses today. Okay. And a quick way to go through this, if we actually look at the OSI, if you look at the comparisons between these two models, you see this kind of breakdown all the time where they basically are trying to show you that this is the OSI on the left and on the right is the TCP model. The one on the left makes no sense whatsoever. It just doesn't work. All right. So, and the reason why is if you look at what happened with the TCP/IP layer, right? If we go through this, let's click that to enlarge it. There we go. That's good. Let's enhance that. This internet thing might just take off. You can't go into TCP dump and write a filter for the presentation layer. You can't. You can't go in and even like session layer be like, well, I want you to create a filter that pulls out the session layer for every single, or the presentation layer for every single packet. How the hell did this disaster actually happen? The reason why it happened is because there was a number of countries involved and they did it through consensus. I'll give you an example. At one point, there was an argument between the people in the United States and the tech geeks from Germany, geek fight, over the application and the presentation layer. In the United States, they were calling it the application layer. In Germany, there was a company that called it the presentation layer. So they got into this fight. It's the application layer, presentation layer, application layer, presentation layer, and back and forth they went. And the solution was to create two layers. That was the solution to the problem, which once again means that's not how networking actually works. Also, if you're looking at how this actually translates, taking this big, huge mess and just clumping it in the application layer kind of makes sense at that particular point because applications can be so varied. And also the applications in and of themselves, kind of not the point of networking. If you think about it, networking is all about transporting that application layer data from point A to point B so the application can deal with it. Your switches and your routers and firewalls, to a somewhat lesser extent, don't really deal with that application layer data so much, but there are differences. So if we're looking at this, we have all of these different cool protocols that exist, like network access layer. We have network access control that deals with that. We have the network layer. We have routers that allow us to do that transfer of data back and forth, be using the network layer, and also the transport layer dealing with ports. Firewalls can deal with ports as well. And then the application layer is handled by the applications predominantly, even though things like firewalls can inspect the application layer, they're not doing it through the OSI model's perspective on how to do it as well. So if we're looking at it, use what's on the left. This is called the Stevens four-layer model. And this is how the internet actually works. Now, even if we're looking at NDN or Arena, like seriously, this is how networking gear works. So it's a much better way to set it up and make it so it makes sense to you. And you're going to see how it directly translates into things like TCP dump and Wireshark. So let's continue on with this. So if we're looking at the IP header, right? So if we're looking at the IP header, we're really looking at this network layer because it deals with that network level data that's being sent back and forth because we have the source and destination IP addresses. We'll get to those here in a couple of seconds, right? So we have the IP version, which most of the traffic that you see is going to be IPv4 and IPv6. What happened to IPv5? It was academic. It was used in universities. It had issues and they replaced it before it got any adoption anywhere with IPv6. So you can get that version. You got the header length, which is length, and we got the type of service or the differentiated services field. We can deal with that, but a lot of times it'll deal with things like deal with things like prioritization on the network on modern. Get to this layer right here, identification. If we look at the identification row as you will, if you're looking at this, the identification is a 16-bit value. That means there's 65,536 possible values. And what is it used for? Well, once again, going back in time, a la Marty McFly, if we go way back in time, we see that there was a lot of different types of routers at different performance capabilities and the size of the packets that they could handle. So you would have a router that would be a modern, newer router that would hand off packets that would have a maximum transmission unit size that would be smaller. So they'd have to do something called fragmentation, where they would take a very large packet and they would chunk it up into smaller packets. And when they broke those packets up, they would use IPID to let the end system know that all of those packets were associated with each other. They all hung together like a nice rug holding a room together. So the IPID, when you fragmented a large packet into smaller packets, was basically a notification that all of these packets are associated. They would all have the same IPID. Then we have the X flag. I'm going to come back to that one in a second. We have the D flag, which means don't fragment, and the more fragment packet means there are more fragments to come. And the fragmentation offset says at what point do you put these fragments to stack them back together, starting at 0 and working our way up. But if we're looking at the X flag, does anyone know what the X flag is there? I'll give you a hint, it's reserved. It's reserved. Does anybody know what that bit? It's one single bit. Right in the IP header, it's one bit all by itself. Yes, X gonna give it to you, It's the evil bit. Now, some of you are horribly confused on what the hell is the evil bit. Let's go to that. So if we go to the Wikipedia, because that's the root source of all knowledge, they have a wonderful little article on what the evil bit is. Now, the evil bit was created by Steve Belvin all the way back in 2003. Now, what the hell is an RFC? A RFC is a request for comment. The entire internet was created by using these requests for comments. So you're going to see me reference RFCs multiple different times throughout this course. We're talking about like the three-way handshake, which is 793. 1918 is non-routable private IP addresses. There's a whole bunch of RFCs that describe how the internet works. And in this particular RFC, Steve Belvin put it out there and said, you know what we need to do? We need to have a bit. This particular bit needs to be used that we can easily identify evil traffic on the network, because trying to determine what is evil traffic and what is benign traffic is very, very hard. So according to this RFC, whenever a hacker is trying to break into your system, they have to set the evil bit to 1 so I can filter all of the different evil bits out of my network easily. And immediately there were people that were like, well, Steve, that's the dumbest idea. I don't think that criminals are going to set the evil bit whenever they're trying to attack. So I'm going to write 19 pages on why I think this is dumb. This is the first April 1st RFC. Came out April 1st, 2003. Okay. It was a joke. And there's been a number of them, like IP over carrier pigeon, the avian transport protocol. There's been a number of different April 1st RFCs that come out, but this one is the first. This also works out as a great way for me to describe RFCs or requests for comments so you can understand how these different things work, because that is where they are described, is in RFCs. Now we drop down from fragmentation. We got time to live. I'm going to come back to TTL here in just a little bit when we get to trace routing. We're going to talk about that, and we're going to reference it back to Motley Crue and politics, because that's the type of class that you just fell into, Alice in Wonderland. Sit back and buckle in. All right, we have the protocol and the header checksum, which is the quick CRC32 style checksum to validate some integrity. It is not a super awesome checksum. It's just a quick checksum. And then we have source address and destination address. That is the IP address. An IP address, for those of you that do not know, the IP address is like a phone number, right? And this analogy is gonna work out, especially when we start talking about DNS and like, phone books and things of that nature. But an IP address is a unique number that is assigned to computer systems on the internet and locally as well. And we call it a dotted quad. So like my IP address at the office would be something like 192.168.15.21. That would be an internal IP address to my office. But then on the outside, my IP address would be something wildly different. It'd be like 24.26.15.18 or something like that. It would be a different IP address because of something called NAT, Network Address Translation, which we'll get into here a little bit as well. But these are the numbers, right? So if I try to go to, let's go to a terminal, quick to the command line. That's not going to work the way I want it to, so we're going to do it this way instead. All right, so if I try to ping a system, let's go ping www.yahoo.com. There you go. You can see that I just resolved IP address for yahoo.com is 69.147.71.248. We just resolved that IP address. And the service that does that is called DNS. And DNS does that resolution between a name to an actual IP address. That's kind of what it does. That's wild. I actually have that exact painting, a duplicate of that painting at my house. Kind of weird. It's not DNS. No way it's DNS. It was DNS, right? But I've got that IP address there. So that is kind of like the phone number for Yahoo, right? If I do this to, let's say, www.google.com, right? Comes back with a completely different IP address here, 142.251.150.119. So we have these different IP addresses for these different numbers that are out there as well. And then we have IP options. I'll talk about that more here in a second. There's a number of different things we can do with source routing. There's all kinds of weird crap that you can do. We don't use it all that often, but you can do like loose source options, strict source routing, and we can do, like, we'll talk about urgent pointers on the next one we talk about that. Different from IP options, but getting into TCP options kind of becomes a grab bag for a bunch of different things. Now, when we're stacking the protocols, you're going to have the IP header, and then you're going to have the payload of the IP header is the TCP header. Well, we're telling it which IP address to go to. What port is it going to? See, how is it in the communication? How do we differentiate communication, let's say, from a university of like Utah or something, where we have thousands of students that are all coming from about the same IP address? How do we differentiate all of those from each other? Well, we can use something called TCP, right? Transmission Control Protocol. Oops, my chat ran off the bottom. There we go. And then we encounter this idea called ports. Now, I want you to think of your computer system as a building. There's a lot of ingress and egress points into your building, right? You have doors. Human beings can walk through human doors. Okay. Then you can have a garage for cars. That works fine. You can have windows that generally allow light in, or if you open them, sometimes wind. You have pipes that bring water in. You have other pipes that take waste away. You have electrical lines that bring that in. I want you to think of your house kind of like a computer. And there's a number of different ways in and out of that house. These would be like ports. Different things would be used on these ports. Another way to look at this, another kind of mental analogy, is I want you to imagine a hotel, a really big hotel. And let's say that this hotel has 65,536 rooms. If you are sending a package to somebody at that address, you're going to use something very similar to the IP address, the overall address, but then you're going to be more specific and say it goes to the specific room. So we have 65,536 possible ports for TCP and then 65,536 possible ports for UDP. Why that number? Because 16 bits have been reserved for that. And it turns out if you look at all the permutations of 16 bits, you come up with 65,536 possible permutations. Pretty cool. Then if we drop below that, we have a source port and a destination. So we have two, right? Where it's coming from, where is it going to go? Where did you get now, Cotton Eye Joe? We have the sequence number, which if you look at this, it goes all the way across. That means it's 32 bits. Okay. Now, what's interesting about 32 bits is the total amount of numbers is not 65,536. It's actually 4.72 billion possible values and change. Why didn't it just double to like 32,000? Like, why didn't it do that? It didn't do that because it's not additive. So every time you add a bit, it doubles the total space. So we're looking at 4.72 billion possible values for a 32-bit number. Now, the sequence number is what allows us to keep the communication separate and distinct. You got to keep them separated. Dun, dun, dun. All right, so if we're looking at that 32-bit, let's say we're all at a university. Like I said, my daughter's at the University of Utah. My kids are up at the University of Montana. If you're in the dorms and you're surfing the internet and you're going to Google, there's literally hundreds of students that are going to Google at any given time. So if they're all just communicating just to the IP address of Google, which is 142.251.150.119, how the hell does Google keep them all separate and distinct from each other on that? So one of the ways they do that is, well, there's a number of different ways. There's web technologies, but the TCP/IP protocol stack, they can do that through the sequence numbers. Each individual connection coming in will get a randomized sequence number. And I'm going to show you the TCP/IP three-way handshake here a little bit. We're going to have some labs with that here in just two shakes of a lamb's tail. And then also an acknowledgement number. It basically says, I acknowledge the sequence number that you sent me by either incrementing it by 1 for the first packet or by incrementing it by the number of bytes that I have received. So it can keep that connected on that as well. Then we have the offset. We've got some reserved bits. We have the TCP flags. The first two are utilized for congestion notification. And then we have the urgent, the ACK, the push, the reset, the SYN, and the FIN flags. Urgent means that there's urgent data within this particular packet, and it needs to be pushed directly into the application without filling the TCP window size, which is right here. And the urgent pointer will show an offset where that data is. ACK means I'm just acknowledging. You sent me something, I'm going to acknowledge that I received it. TCP is very heavily focused on state and making sure that what was sent was received, and we keep that state proper. Push means ignore the window and push it directly into the application stack. Reset means something got wrong. Let's start over. Let's just do a do-over. Let's just do a reset. SYN means I'm starting up a connection, sequence request. And then FIN means I'm at the end. This is the end. My only friend, the end. Don't forget to ride the snake. All right, that means it's the end of the communication. And window size is the amount of data that's received by the receiving operating system before it flushes its buffer and sends it into the application. All right, then we have another checksum, once again, and then that urgent pointer that I was talking about. The checksum, like I said, it's not a super strong hash value. It's just a quick and dirty checksum. All right. UDP is a different protocol. Where if you look at TCP, there's all this really heavy focus on, what is, did I receive this packet? Did I send this packet? Making sure that everything's been sent, received properly. And it was created because DARPA was worried about a nuclear Armageddon situation. We still needed to communicate with each other. So picture this. If you have, like, let's say a mountain down in Colorado Springs and it's trying to communicate with a data center in Kansas, If nukes landed, then you would have radiation. And that would introduce corruption to the TCP stream. So they had all of these different checksums to make sure that everything that was sent was received and so on. What they failed to remember is if we were in the middle of a thermonuclear war, it doesn't matter because copper melts in nuclear Armageddon. There would be no packets traveling, and there'd be nothing worth talking to. At any rate, they were really worried about that. So TCP is all concerned with state. Then we get to UDP. UDP, we joke about it, is unreliable damn protocol. It's what we refer to as a fire and forget protocol. We're just going to send packets, and if you receive them, cool. If not, not so cool. I kind of think of UDP. I don't know. Have you guys seen like the Riz, the Harry Potter? It was created by AI. It's absolutely hilarious. If somebody can find a link, but somebody did an AI for the new Harry Potter. If it was like modern Britain, and it's like straight up Riz level Harry Potter, and like Dobby shows up and he's got like a big drink, and like they're wearing lots of gold chains, and they say type shit a lot in it. Somebody can find that, but you know, with UDP, it's like Dobby driving. It just doesn't care, man. It just doesn't care. We call it fire and forget. It's just going to get it out there. It doesn't matter whatsoever, right? If we're looking at this, we have source port, destination port, length, checksum. That's it. Now, that doesn't mean that UDP is bad. It just means that UDP is built for different purposes, right? UDP is built for streaming traffic, a lot of times like streaming music and movies, where if you drop a couple of packets, doesn't really matter on that as well. So that's it. If you want another way to think of it, Brick, think of UDP as unreliable damn protocol. It's just fire and forget. Now let's talk a little bit about the TCP/IP three-way handshake, right? So we have a SYN packet, we have a SYN-ACK, we have ACK, and we have established connection. That goes back to these sequence numbers that we're talking about here that are 32-bit long. So if I send you a SYN, it's going to have a unique 32 pseudo-randomly generated 32-bit number. You will respond back by acknowledging that sequence number, and you're going to start a brand new sequence number on that. So no, that's not, you got the joke wrong. It's not I tell you a UDP joke, but you probably wouldn't get it. It's I tell you a UDP joke. I don't care. I have a UDP joke. I don't care if you get it. See? It's the difference. If we want protocol jokes, if that's what we're after here in this class, if that's where we're headed, there is this website called Protocol Jokes from attrition.org. There you go. So now, yeah, there we go. So you've got that right there. If you want all the protocol jokes that you could possibly handle, this is the place to go. All right. So I send you that SYN packet. We got a SYN. We communicate with a SYN-ACK, and then we just communicate through a series of ACKs. We're just constantly acknowledging what we actually received. So it goes SYN, SYN-ACK, ACK, 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 ACK. Have any of you ever seen Mars Attacks? Anybody? Mars Attacks? Yeah, you have. Okay, good. I worry about getting too old, but this movie, classic. Absolutely classic Tim Burton movie. It's amazing. If you remember the Martians in Mars Attacks, they communicated through a series of acts. They'd be like, I am convinced that Mars Attacks is an in-depth introspection on the TCP/IP three-way handshake. I'm convinced that somewhere on the cutting room floor in Tim Burton's studio, there was a scene where a baby Martian came into the world, said SYN. Mom said SYN-ACK. It communicates through a series of acts until the day it dies, which it would say Finn. But you never saw that in the movie because their heads exploded due to country music. I digress. All right, so what are the main ports that you should know? These are the 10 ports that you should know. You can go really far in your career and job interviews by just knowing these ports. And these ports are the top 10 ports that are recognized and known by insecure.org, by the author, Fyodor, of Nmap. So we have web traffic, telnet, HTTPS, SSH, terminal services, DS. We're going to talk about those protocols a little bit more, FTP, remote procedure call, and SMTP. These are the main ones that you should know. However, these ports are a little bit different. The hell? All right, I guess we're gonna do a Scapy lab. You all are gonna need a different code. I'm gonna have to get you a different code. Just give me a second here. Let me log out of this one. Log into this one. Hey, I don't think, just give me a second here. I'm going to stop sharing. We're going to talk about Scapy, and then I'm going to get you guys into another lab server. So we've got the instructions to get into the lab, but you need codes to get into the lab. If somebody could post in for SYN, how to get into the lab, we'll do that. So what we're going to do now is we're going to create packets. We're going to create packets from scratch. So testing IDS and IPS and SIM rules with ground truth level traffic, right? We want to be able to replay that attack or benign traces to validate packet level forensics, automated and automatic network discovery. So if we're looking at Scapy, if you remember, I talked about how you can stack these protocols on top of each other. So you can run Scapy and you can do from scapy.all import IP and TCP. So we just imported the IP header and the TCP header associated with Scapy. So now we've got a packet and we've got the, we're going to create it and we're changing one header value. The destination is 8.8.8.8 and the destination port is 80. So now if we want to see that packet, what does it look like? When we're building that packet from scratch, this is what it looks like on this as well. So hold on a second. Let me get Tim. I've got it on my other computer system.
So, John, just to clarify, this particular lab is not in Cloud Labs. Is that
It is in Cloud Labs. It is, but it's in a different
class?
It's a different one. It's in this Rita lab. I've got to get them.
Oh, gotcha.
So can you call Tim and have him text it to me?
Yeah.
ASAP. So they'll get both. They get both the lab environments. They get both.
Okay.
And I'll walk through that. How to redeem that here in just a second. So they get both of those lab environments. So give them a call, please. All right. So if we're looking at a packet, if we do like packet show, we're able to print out the entire header information for all of that different protocol. Now, one of the things that are really cool, we are going to use that one, Rivon. We're going to use SOC core skills. We will absolutely be using that one. But for this lab, we have a different super VM to give you guys. Let me do a search for Roman. Trying to get the code. I have it. That's what I get for using a different system. Tim has it. He'll get it to us here shortly.
Yeah, I'm trying to get in touch with him. He's out of office, so I gotta get.
Yep, I think he's in Oklahoma right now, but he should be ready to go.
Okay.
I can get it here in just a couple of seconds. I will. Actually, I'll hit up Roman. Not Toman, Roman. There we go.
Why do you keep going with that?
Actually, wait a minute. I actually, hold on. I might be completely smoking crack. Just give me a second.
I might be.
I might be smoking crack. I think it might have been already ported over to Kali. I think I would have this stuff down, wouldn't you?
Well, I mean, you'd like to move things around.
But let me see. Nope, it's ported over. We're good. We don't need
just watch that. Panic crisis averted.
I got them all excited. Should I give them the Rita lab anyway?
Yeah, just do.
I think we should because I panicked them. Yeah. There, we got the Rita lab. Kill a Mind Hacker got it too. So that is the Rita lab. I'm going to take that code and I am going to put it over into resources. And I just got you guys a whole bunch of new labs working to compress and consolidate all of these, but you got it. Thank you so much, Jesse. We got it there, but you do not need it for this lab. You can go right into the standard SOC Core Skills lab. Everything's going to work just fine. You just go into here, SOC Core Skills. I forgot that we updated it, so it does work in the Kali version on that as well. Okay, here we go. All right, so let's keep going, and then we're going to get into a lab. Now, one of the cool things about Scapy is it has default templates for a wide variety of different protocols that are out there. Ethernet, ARP, IPv6, all of those different things, TCP. So you don't have to build things from scratch. It has all the different header fields built in with default values, and it will also automatically go through and modify the ones that need to be randomized, things like sequence numbers and things of that nature as well. Which brings us to the lab. All right, so I've got my Cloud Lab system set up. I'm going to go ahead and close some of these things out because I don't need them. And I'm just going to open up the lab that we're going to be doing, and I am going to push that in here. Jelly Beanster has shared instructions on how to get access to the Cloud Lab instructions for SOC Core Skills. So you'll be able to follow that. There is a code in there. The biggest question that we get from people when they go through these instructions, it's like, enter this access code. And they're like, what's the access code? The access code is right here. It's SCS4CE8. It's there and it's present and it's accounted for. So my VM is already running. So I'm going to go ahead and start it up. There we go. And now it's going to get running. Now our labs will run for 4 hours and then automatically shut them off. When you are going through and you are doing this, you can shut off your VM in between labs to save lab time. As part of this class, we provide everybody with 16 free hours of lab time for this course. So everyone gets 16 hours. And then after that, you can buy more credits up here with billing and credits. You can purchase more credits to do that. When you first start the VM, you want to start all virtual machines right here. Start all of them. Don't start them individually, just start them all. And then it's going to count down for about 2 minutes, and then you'll be able to access that VM from your browser. And I'll be doing a walkthrough of this for everybody here in about half an hour. So what you're going to do is you're going to learn how to build a packet from scratch. Now, I know this seems like we're dropping in hardcore right off the bat, but we have to understand how packets are structured. And this is a great tool to show you how you can actually get down and just create packets from scratch. It also becomes a powerful AI tool because if you're working with AI and you want to write something, let's say you don't know any code at all, you can sit down and say, please write me a Python script using Scapy that has the following attributes, and AI will write that for you, which is pretty cool. So we're going to build packets from the ground layer. We're going to start by clicking on the Kali terminal. It's going to take a little while to start Scapy. You're going to become root and you're going to run Scapy, and it can take a little while. There's a lot going on to load up all the appropriate libraries for Scapy. Okay, takes a little bit. We're going to do the most basic structure associated with this, and we're going to create a raw packet. You can take this and you can type it in where you can actually copy and paste too. That's what I do. You can copy this command right into Scapy, and it's going to say my packet's going to be an Ethernet and an IP header, and it's going to grab those two bricks and stick them together. Then you can do mypacket.show. We're telling Scapy to show the variable we just created called myPacket, which includes the Ethernet and the IP header. And these are all the header things that we just talked about. Then we can ping BHIS. We can do send and received IP packet. We're going to change the variable to be the host name of www.blackhillsinfosec.com, and we're going to put it into an ICMP packet. It's going to send and receive those packets to us. Now we can check to see if port 80 is open on that by sending a SYN flag to port 80 in the TCP header. Then we can scan a range as well. Right here where we have the 1,100, it's going to go 1, 2, 3, 4, 5, all the way up to 100 to see what ports are open. And then we can view the actual raw results coming back. We can also sniff from Scapy. This is going to become important when we talk about TCP dump as well. We're going to sniff packets on our system. And then we can look at packet templates. What types of payloads can we do with this? We have all these different protocols. There's a lot of protocols that we can do on those as well. We can do traceroute, which I'm going to talk about here a little bit later in this class as well. We can create a raw DNS packet. Now, this is cool. We're doing a packet. We're going to call it DNS query. We're going to send it to 8.8.8.8, which is a public kind of phone book that allows us to query DNS directly from Google. We're going to do UDP on port 53. We're going to create the application data is DNS, and we're going to put in the query name www.example.com, and we're looking for the A records. And then we can send and receive that data. All right, so I know this can be a little bit intimidating, but the way we do this stuff, all of the stuff I just did is copy and paste. Lots of instructions. And at the end of this lab, I'm going to come back and I'm going to do it with you. So let's go ahead and let's put 40 minutes on the clock for this one, because we want to have 10 minutes for the break and 30 minutes for the lab, and then we'll come back and then I'll do the walkthrough. So Daryl, are we ready? Or Kevin? I don't know who's setting the clock.
Yeah, we are.
I think Daryl's ready. And by the way, we just freaked the hell out of Tim. Just so you know, he called me and he was like freaking out.
No, we're good. We're good. It's my fault. I shouldn't cause. And then Tim's like, you could totally use that brand new environment that we just got done last week. And I'm like, no, let's do old standby this week.
Yeah.
So get rolling. I'll see you guys on the other side. Hello and welcome back, everybody. We are ready to do this lab. Let me bring up the Discord server. All right. So one of the things that I want to acknowledge, like right out of the gate, is it is very common for people when we get to this particular lab. Don't want to say they freak out so much as wow, that's really awful. I got all kinds of lighting options. I think my camera hub's fighting with my standard lighting stuff that the Mac does. Anyway, so whenever we jump into this, I think it's common for people that are just kind of getting started to be like, what the literal hell are you doing to me? Like, we're going straight into the command line. Are you insane? Yes, that would be a true statement. However, this is a really great way for people to kind of get started learning the Linux command line. And really, I can't think of a better way to learn packets than by creating packets. The other thing to remember is that all of these labs, they are all basically here for you to keep doing so you can drill and you can get used to these things. Also, if you're looking at how this lab is structured, and what we're doing in this lab, if you're working with AI, it's going to be very common for you to ask AI to create different scripts, to create different things for you based on what is needed. And having a little bit of understanding, especially when we're talking about packet creation, a better understanding to be able to like give it, I want to create a Scapy file that allows me to do these following things, gives it more context to be better. So we're going to jump straight in. I'm going to become root. Now, the reason why I'm becoming root with this particular command is because we are running like raw TCP socket access. We are literally straight up creating packets on the wire, and that requires a very high level of privileges on the computer system to be able to do that as well. Then we're going to start Scapy, and it takes a little while for Scapy to start up and get running. Like I said, it's a fairly robust Python program that exists, and a lot of people use it. I remember the first lady that got me introduced into this was Judy Novak, which is just, she was amazing. She's like a big sister to me. Literally wrote the book on intrusion detection, which literally, if you look up the book Intrusion Detection, she's the author with Stephen Northcutt, and she got me hooked on Scapy a long time ago. All right, so now we're in the Scapy environment, and it's in a Python environment. So we're inside of the interpreter Python environment for Scapy. So think of this as like a full toolkit for everything you would need for packet creation that you would ever need for packet creation. So now we're going to create this variable called my packet. That's the name of it. I can call it John, Bill, whatever. It doesn't really matter, but I'm going to call it my packet. And we're going to have the Ethernet header and the IP header. So if you remember, I talked about like you would have IP and then TCP, or IP and then UDP. Ethernet would be one layer below that. That would be layer two on the Stevens end on the OSI model. That's like how your computer system talks to the local switch. I've got an Ethernet cable running around behind me, and it goes into a switch. And every single computer system in the world has something called a MAC address, media access control address. And this is a globally unique or pseudo unique identifier for every single network adapter on the planet. You have a different one for your wireless card, for your Ethernet card, and all the computers should be different. And under normal circumstances, they would be, right? But hackers can change that. But that media access control number is what is stored on a switch where it'll learn which port your computer system is plugged into. So that's called the Ethernet layer. So we're literally just creating a packet called my packet. It's straight up Ethernet and IP. Now, I want it to show me what is in that packet, right? And here you can see the Ethernet header. I don't have any destination. It says resolved on build. So whenever I try to connect to the internet, okay, let's say I'm trying to go to Google, that Ethernet header is not going to persist beyond my local network segment. So it'll send the traffic to the router, the main router, like the one you buy at home. It'll send it to that MAC address. It'll strip it off and then forward it to the proper IP address, and it resolves that on build. And then I have the MAC address right here, and I can change that to be whatever I want. And the type says IPv4. Then in the IP header, as we were going through the IP header, we have the version, the IHS or IHL, sorry, type of service. We have the length, we have the IP ID. We don't have any flags. We don't have any fragment. The TTL value starts at 64, the protocol. And then of course we have the checksum, and then we have the source and destination, right? So that's the default packet. And we can change any of those values that we want to actually send a packet out on the internet. I can't change the colors, unfortunately, but it'll get a little bit better here. You know what? On Mac, how do you invert color screens? Hold on, let me check that up. I might be able to do an inversion. There used to be a hotkey. Control Option Command 8. That did not do it. Oh, wait, let's do this. It's under accessibility features. Woo. That's a little hot. That's a little hot. Oh my God. Anybody tell me my mouth was that scary? I don't know if that's better or worse, chat. Yeah. So, all right, here we go. I'm just going to go back to this, and we'll mess with it a little bit later. What I can do is I can make it more bold. I can make this the font a little bit bigger. I don't know how to go in and change the color choosing for it. Let me change the font. Let's go bold, go to 20. That blue is kind of tough to see. There we go. Oh, that's much better. There we go. We'll just do that. All right, so we're going to do this. And next, what we're going to do is we're going to change one of those values, right? So we're going to do this. We're going to go send and receive. We're going to change the IP value right here, where dest is going to be www.blackhillsinfosec.com. And we're going to send a ping packet to www.blackhillsinformationsecurity. We received 5 packet. We got 1 answer. So that means that it was responding to that ping packet that we sent. Now we can do send and receive and see if the SYN packet is open, or the SYN port, or the port 80 with send and receive is open. Comes back and we got 1 answer. We got 1 result for TCP. And then we can look at all of those and send a whole bunch of packets. So we just sent 100 packets. Now let's say we wanted to see the results of each one of those packets that we sent. We can do answer summary. like so. And there it is. Saw that SMTP was open on this one computer system. All right. We can look at what's unanswered. A lot of packets. We got to reset ACK. All right. Then we can sniff packets because there's packets coming and going to the system all the time. We see a ton of like SSH being sent to this as well. Takes a few moments. There we go. And those are our packets that we received. SSH, of course, which makes sense. And then we can look at all the different protocols that Scapy can support because we just showed you a handful of couple of things. What we're sniffing for is packets. Let me open up another Kali terminal. Let's go interface any. Oh, you can make this bigger too. Let me show you what's going on. So whenever you're looking at packets and you're trying to understand what's going on, one of the things you need to know is your computer is constantly sending and receiving data on the internet, okay? To send, which is an app name, by the way. So I can do TCP dump. Go TCP dump. And I'm going to put in an interface of ETH0, like that. And now these are the packets that are coming and going on my system all the time, right? And you can see it's giving us the header information. We're going to have a lab with TCP dump here in just a little bit. Nope, it's not another word for filtering. You're sniffing all of the, I'm sniffing right now all the traffic that's coming and going to my computer. And I can do some additional flags so you can get a better idea of the random data that's being sent. But we can actually see the full data that is being sent and received on this. So sniffing allows me to sniff and view the packet data that is coming and going on my computer at any given time as well. All right, so there's a lot of different things that we can do. We can do trace route, which I'm going to talk about more here in just a little bit, utilizing Scapy. There we go. So we're going to send packets to google.com. Max time to live is 8. Timeout is 5. And we can trace what are the routing hops that my packets are going to go to in order to get there. And I can do this from the straight command line as well. So if I go right to the command line, I can do trace. I'm going to do trace route. And then I can go 8.8.8.8. We're going to send it to Google. And it says the first routing hop is going to be 10.10.62.26. That's the edge router. It's going to pass it off to 243.80.10. That one's going to pass it off to 240.64, 220, 130. We have this one is just not responding. It doesn't mean it's not there. It just means it doesn't respond to trace route whatsoever. This one is going to be 99.82, 181, 23. And then dns.google.com is the end state of that. So there's 7 routing hops that are sending the routers between me and the end system. And yes, being able to sniff traffic is very, very, very powerful when you're trying to do incident response. So now we have a DNS query. We have IP. The destination is 8.8.8.8, which is literally what I just did here with this one, where I was able to talk to Google, but I can do that programmatically inside of Scapy as well. And I can get those responses back out, or I can do send and receive DNS query. I want to see the output that it gives us. And right here, it's kind of looks bad, but this is really good for computer parsing. It's kind of like JSON. We send the packet and then we get the response back of example.com and what IP address example.com is at, which is right down here, 104.18.26.120. All right. So that's the lab. All right. So that's the first lab. That's a number of you just jumped right in and we're creating packets. Now, how do we actually take this into something that's more useful and understanding what's going on? Well, when we have those IP addresses, we can start looking at things like Shodan. Now, Shodan is a fantastic tool that is basically querying the entire freaking internet all the time. Let me go into Shodan real quick. Let me share this link with you. There we go. I'm going to log in with my Google account. There we go. And I can do a search for like Mongo databases. So what do we have for Mongo databases that are directly exposed to the internet? There's 107,000 of them. Jet Direct, right? These are Jet Direct printers. There's 2,302 Jet Direct printers plugged into the entire internet. We can do, let's get a little weird. Let's go to a live demo of something on the internet. And by the way, I'm going to warn you, this is a live demo. I don't know what's going to happen. There might be some icky things that show up on that as well. So I'm going to do port 5900, which is used for visual network computing. And check this out. There's 965 results. And if you want, we can actually go even further and filter it down to ICS systems. These are all industrial control systems with no security, no login, no user ID, no password, directly exposed to the entire internet. And there's 245 of them. Now, a lot of them are like water treatment facilities, things of that nature. But there are some actually really scary, well, water treatment facilities are kind of scary, but you'll see sprinkler systems. I don't know what's going on with this one. This one is intense. A lot of ports open on this one. Yeah, this just looks bad on so many levels, right? It's crazy. But yeah, no security whatsoever, right? So that's kind of nuts. Now, the main ports that Shodan looks at are these, right? Probably not, Jennifer. If they were bug bounty, like they would probably already be taken down. A lot of the organizations that have these types of vulnerabilities that exist like this on Shodan, they're so behind on security, they don't even know what a bug bounty program is. And honestly, they probably don't even know that these devices exist on the internet as well. No, resonating. They're not all honeypots. In fact, Shodan actually has, if I go back to main Shodan and I do SCADA, Shodan actually identifies honeypots, like this one in Jakarta. So this is a SCADA honeypot, and Shodan was able to identify it. So it actually does go through and tag them as such. All right, so now we're going to get into yet another lab coming up here in just a second. We have TCP dump. We can list out all of our interfaces. You saw me do TCP dump space -I, lowercase I, that is, and then ETH0. I was sniffing on my Ethernet 0 interface. And with X, I can see the hexadecimal data, and A, I can see the raw ASCII data as well. I can put in additional filters associated with this, where I can read the data from a file, from a previously captured file, and that's what we're going to be doing here in a moment. But I can put in filters for specific hosts and ports as well, and I can write out to a file. But you know what? Best way to learn TCP dump is to use TCP dump. All right, so that brings us to our next lab. Let me go back to the lab directory, and we're going to do TCP dump here. Jesse, thank you so much. And once again, we're going to be running inside of our Kali instance. You can close out your previous one. Just start from scratch there. Just close those. And let's open up a fresh Kali terminal. And we are going to change our settings, change the appearance. Go bold, 16 for me. I'm just going to do this now. And then we're going to open up. We're going to become root. We're going to CD into the TCP dump directory, and then we're going to read in a file of a system that's been compromised. The backdoor was a tool called Magnitude. It ran for 1 hour in our lab, and we're going to filter on this host, this 192.168.99.52. Now, let me give you a use case. Let's say the user of this computer system that's at 192.168.99.52, say their name is like Susan. Susan calls you up and says, oh my God, there's a dancing gerbil on my workstation and it's running all over the place and it's literally eating my desktop icons and I cannot kill this gerbil that's on my screen, right? Look at it, gerbils are adorable, right? But this is some gerbil malware level stuff. So if you wanted to do some research, well, you could see, is there any potentially malicious traffic coming and going to that IP address? This would be a use case of how you would get here. We would sniff the traffic, do that in a number of ways, and then we put in a filter to get only the traffic for her computer system, right? Then what we're going to do is we're going to look at there's any traffic that is destined to port 80, i.e. web traffic, and I want to see the ASCII decode of that traffic as well. Then we're going to read in that data, and we're going to look at the ASCII and the hexadecimal data associated with it. Then if we're done, we're just going to play around. We can do IPv6, and we can look at entire network segments as well. So TCP dump can be used to sniff traffic, but it also can be used to read back out the traffic from a system that we believe to be compromised. And that brings us to the next lab. This one's not quite as long. We're going to do a 10-minute break again, right? We're sniffing gerbils now. No, we're sniffing promiscuous sniffing backdoors. Oh, that's weird, but that is a thing. So we're going to do 10 minutes for the break and then 20 minutes for the lab. We will start at 30 after. So let's get the clock going. And I'll see you on the other side. Lab timer coming up. 30 minutes. I'll see you in a few. So you know what helps? Actually, just throwing this out there, mothballing, unmuting your microphone when you have to chat. It's a really helpful next step to make this stuff go. So all right, so let's go ahead. Let's get to this lab real quick. All right, so this lab and the next lab are kind of showing the same thing from two completely different sort of angles, right? So we got the idea that, we can create packets. We can work with packets at a very low level utilizing a tool like Scapy. But now we're starting to do some level of analysis on those packets to try to understand what is actively happening on the network, dealing with a potentially compromised workstation. Once again, talking about the IP address we're reviewing, once again, say that somebody's computer system is compromised, right? And then how do you start investigating that from a network level? By the way, I've got a question, a trivia question, pop quiz, hot shot. Somebody has the Cookie Monster virus on their computer system. What do you do to stop the Cookie Monster virus? Let's see if anyone can get that answer on that. So we've got the type cookie. Very good, very good. Digital Orcamai said, is TCP dump the standard? Yes. TCP dump without question is the standard. I have no idea what's going on with my camera. It looks fine, and then it just gets all kinds of weird. But yes, it is absolutely an industry standard in the industry as a whole. There we go. Maybe that's better. Yeah, you type cookie. And for everybody that's now completely confused, what movie is the Cookie Monster virus from? Does anybody have a taker on that one? Yep, the movie Hackers. Very, very good. Very good. All right, so let's go through. And by the way, that's not representative of the way computer security. That's not how any of this works, right? But it is cute in the movies. So the first thing we're going to do is we're going to look at this packet capture, and we're going to just filter for the specific host to try to get the information about do we actually have any data associated with that host? Now, how would you get this? If you were working an incident as a SOC analyst, you would work first with your network team to say, I want the traffic from this host, and then you would get that network traffic. So we're going to check to see if that packet capture has the data. It does. We've got all the traffic from that system going out to the internet. Each of these lines represents an individual packet of data. Looking good in the neighborhood. Then we're going to see, do we have any web traffic? Just kind of try to do some level of filtering on that. Sure enough, we do have some web traffic as well. So we have all kinds of things going back and forth. And then we can actually try to see the full ASCII decode for the data here. So I'm going to go ahead and do that capital A filter. Now, why do I want to show the ASCII decode? Actually, let me show you this right here. Whenever I do just this, these are all packet headers. It's not showing me any data, right? It's got a date timestamp. It says it's an IP packet. This is the source. This is the destination. The little arrow is the direction. What flags do we have? What is the protocol? What's the length? If I want to see the data itself, I can put in like a X to view the hexadecimal data. And I can see on the left, I have the hex. Let me kill it here for a second. This is hex. This is ASCII. Now, what is hex? Right. So whenever you're thinking of hexadecimal, you gotta, if you want to watch a movie that has a really good example of this, you should go see The Martian. I know that the Hail Mary movie is out right now by the same author. Fantastic movie. But The Martian has in it, and he's trying to communicate visually with Earth, and he has very limited bandwidth to be able to do so. So he's communicating in hexadecimal. So if I do man ASCII, we have these tables that exist that convert what you and I look at. You know, we're looking at standard ASCII characters and how that corresponds to hexadecimal characters. So a capital A is 4-1, a capital B is 4-2, a C is 4-3, and so on. Now, why do we send data and why do we send it in hex? Because hex is one very easy step up from binary. Um, when you're looking at a bit of data, that's a 1 or a 0. When you're looking at a byte of data, you're looking at 8 bits. So you have like, you're looking at like, think of like Nintendo cartridges, 8 bits, 16 bits. You're looking at the number of bits that are in a byte of data. So if you're looking at if you're looking at like hexadecimal, it's a way of representing that data in a very quick and easy manner. To be honest, I've only come across a couple of people that can read hex like you and I read books. It's an amazing skill. I mentioned Judy Novak, Mike Poor, Stephen Northcutt. There's a handful of people out there that can read hex pretty much like a normal human being reads things, but those people tend to be very rare. Because we don't read hex directly, then we predominantly read ASCII. And when we're displaying this data, TCP dump is showing us on the left what is the hex in the data, and on the right, how that ASCII actually corresponds to it as well. All right, so if we let this run, let me do this real quick. Let's go here, let's go like this. I'm gonna read that in, I'm gonna pipe it through less. Pipe? What the hell is going on there? What am I doing wrong here? Let's give it A, pipe it through less. There we go. We're looking at the actual raw ASCII now. I don't have the hex here. I don't want to see that because that kind of confuses people a little bit, and that's fine. There we go. And we can actually see what's being sent. So we can see we have GET requests. This is standard HTTP request data, right? And it's going to the Bank of Botswana. I'm sure that's legit, right? Like we all have accounts on Bank of Botswana. Anyone? Anyone? All right, maybe not. But then we get to this. What's this right here? We have this new object IO memory stream where we're converting it from base 64. That's strange. What do we have here? Let's say that you're just approaching this as a junior analyst and you're like, I don't know. I don't know what this is. What could we do with that? So what we could do is we could go to like Chat GPT. We went to Chat GPT. And let's just ask it, Let's see what Chat GPT has to say about the matter. It's thinking. That's cool. Yeah, Doc's webcast is awesome. Oh my God, it's decompressing now. Chat, you seeing this? Like it used to just explain it, and now it's doing a decompression of the gzipped payload. That's in the biz. That's something we call hot. There we go. So it's going to go through and say, this is the beginning of a PowerShell payload, new IO object memory stream, taking a base 64 encoded blob, loading it into memory. The string starts with H4SIA, which is very common. It's actually a gzipped compressed data, and it decodes the data directly. Ooh, look at that. Isn't that nice, y'all? Yeah. There we go. It's almost and certainly compressed PowerShell script loader stage that's trying to hide its real code inside of base64. It's a reflection Win32 API resolution, get proc address. Yeah, that's good stuff, y'all. Sweet, sweet data. Should we leave you two alone, John? Yeah, it's just me and GPT, but that's really cool. And for those of you that have been taking my class for a while, like Roswell and Jesse and a number of you, like think about the first time that we did that and now where it's at, right? So it's getting really, really super good at taking something that looks suspicious to us and actually allows us to kind of pull down and get additional data out of it, right? So that's cool. All right. So we can look at all of that data and we can parse it out. We can also do additional filters in TCP dump. Like, do I have any IPv6 data? I sure do as well. Can I look at an entire network of a range of computer systems using classless interdomain routing on that? And I sure can as well. So so far, that's pretty cool, right? But now we get into a little bit of problem, just a little bit of a problem. Let's say that you don't want to spend all of your time in TCP dump. And the problem that we get into at this point is a lot of people are like, well, there's got to be better tools. I've seen Network Miner, I've seen Wireshark, and that's better than this tool. And that's not true. These tools are all different. They have different use cases in the different way that we would actually pull and try to interact with these results as well, which brings us to the next part, Wireshark. Now, Wireshark is a tool that's very similar to TCP dump, but it's actually very different. Wireshark is completely GUI based, right? So if I go in here and I open up Wireshark, I can look at the data that's being sent and received to this individual computer system. So just give me a moment. Remind me later. Let's go ahead and just do Ethernet 3. And this is showing me the actual data that is on my computer. So if I take something and I go ping, let's go 8.8.8.8. This is the packet that goes ping. And I ping these packets and I send 3 ICMP echo request packets. I can go up here and I can create a filter. Let me stop this. Who's down with ICMP? Yeah, you know me. And these are my ping packets, right? So this is going to show me those ICMP echo request packets and the responses coming back from those. So here's my first request, right? And at the top, it shows me each individual packet. And I want you to notice that the source and destination switch, because here I'm the source and I'm talking to Google, and then it responds back to my IP address. So we're seeing the request and the reply, right? So we can see that. So we have request, reply, request, reply, request, reply, request, reply, which is standard for Microsoft ICMP echo requests that are being sent. Now, if I want to know what's going on, you can see down here, I have that TCP dump data, right? So I have this TCP dump data that's showing me the hex and the corresponding ASCII, but let's say you don't know what that is. I can click anywhere inside of this hex and notice on the left-hand side, it's highlighting, like if we go 03003C, that's the total length, right? If I go to 8658, that represents identification. And then I have nothing associated with fragmentation. I have time to live. You see, it's decoding that hex for me. And it goes both ways, right? Like I can go over here and say internet control message type 8. Okay. I can highlight that on the left-hand side. And now on the right, it's saying that type 8 is that little byte right there. Code 0. We have the checksum is a correct header checksum. And then we have the identifier. You can select any of these and it'll highlight what it is. And then down at the bottom, I can go down to the data right here. And you can see the data is A, B, C, D, E, F, G, and lowercase a is 6.1, lowercase b is 6.2, lowercase c is 6.3, and so on. So this allows us to decode what those individual packets are that we are seeing from Wireshark. So we can easily see that traffic that is being sent and received. And I just did an analysis with ping. We have the slides on this as well. And then we can highlight the different parts of the packet to get a full breakdown for what that individual packet is. Now, the other thing that we can do is I can do TCP and I can right click on that and I can go follow TCP stream. Now, instead of trying to look at every single individual packet and try to stitch it together, I can have Wireshark automatically do that. Remember we were talking about the sequence numbers? We have the SYN, the ACK, and then the ACK. Wireshark has the ability to actually pull down all of those sequence numbers, parse that data out in such a way that it'll stitch those individual packets together. So you can see what's going on. So let me show you that in something that we have that's encrypted. So the data that you're seeing here is encrypted. So let me go File, Open Recent. I'm going to open up Magnitude, which is what you're doing in your lab here in a second. I'm going to clear my filter. There we go. And then in here, I can look for these green sections. I can right click. I can go Follow TCP stream. And now I can see the requests in red and I can see the responses in blue. This is incredibly powerful, right? Because now I'm not just working in a command prompt, right? I've got the individual GET request going to the backdoor, and then I have that response. And I have that exact same response with this TCP, or sorry, new object IO memory stream that we just shoved into ChatGPT. You see, this isn't encrypted data, but it's definitely encoded. This is an example of an attacker that would do something like trying to hide in plain sight, right? It's not going to encrypt it, but it's going to do some type of encoding. And in this scenario, it's going to use Wireshark. Or sorry, it's going to use base 64 in that encoding. And we can actually see that raw encoding inside of the packets stitched together by Wireshark for us. So this makes it a lot easier for us to carve this data out from this TCP stream that we are looking at as well. We also will use this for statistical analysis. And to be completely honest with you, this is one of those predominantly, like when you're jumping in and I'm first jumping in, I don't jump right into packets. I actually start with statistical analysis. And the reason why I start with statistical analysis is I'm looking for outliers. When we get later on in this class, as the week progresses, we're going to have more of this where we can do some like frequency analysis, beaconing analysis, trying to identify payload consistency patterns. But I'll do some really high level statistics. And I do this through statistics endpoints. So I can go here, I can go statistics, endpoints, and it's going to show me who are the systems that are talking to each other and who is sending the most data back and forth. So right here, I can see that this computer, 192.168.99.52, is sending 31,602 packets. That's my top talker on the network. At the bottom, I can see who's only sending a handful of data back and forth. So this allows me to do that. I can also look at it in a different way. I can go statistics conversations, select IPv4, and I can sort by packets in here. And now I can see who is that system talking with. So I can see that 192.168.99 is having a conversation with 68.183, 138.151. They've sent about 25 megs back and forth between each other. So I can take this as well. Yeah, these are amazing whenever you're doing an investigation, Jennifer S. Absolutely. But wait, there's more. Because I can take this, I can right click and I can go apply as a filter any traffic between A and B, and then bam, on the back screen, this is all of that communication. It automatically created that filter where I can see the IP address and that equal, we're doing a comparison, so we're going to verify it's not assignment. 192.168.99.52, ampersand, we want to see another one as well that has IP ADDR equals, we're doing a comparison, we're looking it up to 68.183, 138.51. I can jump right into this. I can right click on this, and then I can do follow TCP stream. And now I can see that conversation again. So do you see how I ended up in that exact same place? But I started utilizing the power of statistics, because the power of statistics compels you. We're able to pull that data back. So very, very powerful. So we can look at those conversations. We can look at the statistics in the protocol hierarchy. Who is talking and what are the different like different protocols that people are using? Well, 100% are using Ethernet. That's good. We don't have any Banyan Vines or IPX data. Internet Protocol version 4 transmission, and you can see that a huge percentage is HTTP traffic in here as well. But that's for my filter. If I remove that filter, we do this, and we go back to statistics, and we go protocol hierarchy, it's going to be a bit different. You see how when I ran that protocol hierarchy, it was running it specifically to what was displayed on the screen at that time, because now it's all over the place, right? Like we have LLM&R traffic, we have ARP traffic, IPv4, IPv6, spanning tree protocol. That's bad. Shouldn't see that. Like seriously, like on your network, if you see spanning tree protocol that's being broadcast to everybody, that's a very good indication that there's a potential vulnerability. So if I want to review that, I just do selected and bam, here's the spanning tree protocol traffic. And that's out here. I got the identifier. What is the bridge identifier? Root path cost. Oh, wow. We're getting into some CCNA land here. But once again, very quick and easy for me to get to that and identify that traffic. Filters, all that coming from protocol hierarchy. Next up, HTTP requests. Now check this out. All right. So if I'm sitting here, let's clear this out. I'm going to start sniffing traffic, right? And if I open up a browser and I go to, let's say, yahoo.com, got a lot of traffic, right? So I'm going to go like this, and I'm going to go www.yahoo.com. That is a really simple request, right? Just a simple request. I'm going to go back to Wireshark, and I'm going to stop. Okay. And now I can do that statistics HTTP requests, and it'll show me all the requests that are made. So I can go statistics, go HTTP, go to requests like that. And we have our requests. We have Edge, Microsoft.com. We can apply that. We can see the requests that are being made, right? Now, I don't know why it didn't see my, it's kind of weird. It didn't see my yahoo.com. Maybe I killed the filter. It just wasn't caught up. Probably killed it too soon. But I can see the individual requests. Now, the reason why that's important and the reason why you want to look at that is whenever you make a request to a website like yahoo.com, it's not a simple request. There's actually a lot of requests, maybe even like 40 or 50 requests that happen here, because yahoo.com is loading ads. It's loading lots of ads. It's loading, a lot of ads. It's just a lot of ads. So what happens is you can get to a 302 redirect where I make a request to yahoo.com, and then Yahoo basically says, in order to render the data for yahoo.com, you have to load the data from all of these other places as well. So there would be a crap ton of all kinds of data here, but it all started from one simple request, right? It would all come from one simple request to yahoo.com, right? It would kick that out as well. So that's really powerful, right? Because when we're looking at this packet capture, you're going to see we're pulling data from weather service. Then you're going to see we got Windows Update, and then you're going to see this weird lonely IP address doing very strange things with the requests as well. So there you go. The other ones we got. All right, so that brings us up to the Wireshark lab. I'm going to close that out. Just going to tell you, like surfing the internet through a session like this, not fun. So yeah, you wouldn't want to use these cloud VMs for gaming. That would be bad. Unless that game was chess or checkers. It would be just fine if it was chess or checkers. So we're going to go ahead and we're going to go back to the lab directory. and we're going to go to Wireshark because that is the next lab that we are going to do. And my video just got really choppy. Close this out. See if that helps. There we go. That seems to smooth things out a little bit, of course. So we've got two different tools we've talked about. We've got, oh my God, who brought up Battle for Westnoth? It's like straight crack cocaine. All right, so you guys want to know the two games that I still play to this day? One of them is Battle for Westnoth because it's amazing. It's a very good game. And then the other game that I play very regularly is, if I play, is Beyond All Reason. There was an old game called Total Annihilation back in the day. And it was really, really just super great. And they kept that game going for years. But it's called Beyond All Reasons. Check that one out. All right. So what is the difference between these two? So if we're looking at Wireshark, Wireshark is really powerful if you're trying to do some packet analysis, do some statistical analysis. TCP dump is one of the tools that you would use for kind of quick and dirty analysis, quick filtering of very large files. Wireshark kind of starts to choke on exceedingly large files. TCP dump tends to be better at that. Also, Wireshark is not something you would be running to do the initial capture on a high-speed network link. You would use TCP dump to do that. So usually my workflow is use TCP dump to capture, use TCP dump to filter to just the IP addresses I'm interested in, then use Wireshark to analyze and do that visualization on that as well. So you're going to go into Wireshark, you're going to open up the magnitude 1 hour PCAP file on that. And then you're going to start doing some of the analysis that we talked about. We have each packet. You can see that it's in order. You can open, you can expand, you can do analysis on all of these different packets. And then we're going to do requests on HTTP. And you're going to see this wilfordcostume.baymoon.com. This is one of those classic examples of which of these things is not like the other, which of these things doesn't belong. Because we have weather, we have updates, and we have Wilford Costume at baymoon.com. Yeah. Which one do you think you're going to investigate first, right? Because we don't want to just jump in and just start like doing crazy analysis. Also, T-Shark is amazing. Init One Tech. Great point. But I think you would agree, learning Wireshark really helps you learn T-Shark, right? To learn T-Shark, you get into the filters, you do all these different things. Windows update is sus. Oh yeah, probably I'm going to up that one. That's a good one. Then we're going to look at the conversations that are going back and forth. And then we're going to get a breakdown of who is talking to whom on that as well. Advice for running constant TCP dump on core switches, don't resonating. Don't do that. Instead, what I recommend doing is Zeek. Zeek is a lot less data and it gets you what you need. And we'll have some labs dealing with Zeek here in a little bit as well. All right, so then you're going to drop down and you can put in the filter. As soon as you do an apply as filter, it's going to automatically generate that filter for you. Then we're going to follow the TCP conversation on that stream. Then we're going to look at other insecure protocols like link local multicast name resolution. And maybe we can make that a bit of a challenge. Why is LLMNR bad for you, everybody? All right, so this lab, once again, 10 minutes for the break, 20 minutes for the lab, and then we're going to do Ask Me Anything. That's right. A lot of you don't know this, but go ahead and start the timer. Wait till it gets to the top of the hour, Daryl. Once it gets to the top of the hour, start it, because at 30 after the hour, I will sit down and I'm going to do Ask Me Anything. We got a lot of people that are getting started in their careers. We got a lot of people that have some job insecurities. They're worried about the state of AI. What does it mean for security? All of that stuff. And I'm just here to answer questions for the students after we're done with the core part of the class. So you can ask me anything you want, anything on life, the universe, anything at all. So we're going to kick it off as soon as the timer hits, because we're going to resume at 30 after. I will see you all 30 after. And we are back again, y'all, and we are ready to do Ask Me Anything. So let me get my Discord over here, and if we can share out the Discord there, that would be super awesome. Number one, I don't know what just happened there. That's really weird. All right. Here we go. We already had one question that I think was pretty good. We had what experience level? Wait, that just went away. I thought I clicked it and it was supposed to take me to it. What experience level do you personally recommend before attempting PNPT? What does it look like different from anybody else? We got a bunch of different things. So with the experience level, I think it's just mainly being comfortable with the topic at hand, right? So if you're looking at like real world kind of pen testing and what you're doing from the Cyber Mentor and that type of capability, like seriously, look at the topics and you should know what those tools include. But I'm going to give you a hint. Anytime that you're taking any level of certification, you need to go through the training materials associated with it. And you need to cover the things that they covered in the training and then try to go beyond and find 3 things that the instructor did not talk about at that particular bit of training. So if you're talking about Nmap, right? If they're talking about Nmap, the different type of scans and how those scans are useful, then I would recommend going a little bit deeper and trying to find additional flags that they did not talk about. And I would start like, what are the most commonly used flags? Because I guarantee Cyber Mentor hit like the big stuff, but drop right below that and be like, what about the dash reason flag? What about timing associated with Nmap scans? What are alternatives to Nmap scans on very large network segments using things like mass scan or ScanRAN style techniques to identify IP addresses and ports and services very, very quickly? So you want to go through and say, okay, this is what's in the content. I'm going to push myself to know 3 things that they didn't talk about in the content. And the reason why, especially when we're talking about certifications, multiple choice, or we're talking about hands-on, that ability to go a little bit deeper forces you to understand the content that is covered. So it isn't so much about the new stuff, but it's really, really about the stuff that is in there. And if you're forcing yourself to understand what's there and then go deeper, you're going to feel more comfortable with the stuff that's present on that as well. Do those soundproof panels work or for the aesthetics? I don't know. You tell me. I don't know, Megan. How was my audio coming through? Was it coming through okay today?
Yeah, it sounds good.
But I've got a huge box of them. It's crazy in Sound Panel Town, all the different things that we've got going. I use packing stuff. I use all these things. But yeah, this whole wall is completely soundproofed here as well. What do you recommend for the CCNA? I don't have any specific one that I recommend, but there are tons of CCNA emulators that are out there. One of the things that I would recommend you look at is a really cool project from the United States Air Force called CORE. Let me see if I can pull that up. Just really, really super cool stuff. Here we go. This is Core. And if you're trying to learn networking, it allows you to run a full virtualized network environment that you can work in that as well. So check that out. To view your view on THM and AI security. Try Hack Me and Hack the Box. Okay, so I'm going to tell you right now, like the was it Try Hack Me or Hack the Box that was doing the training? When people were taking the exam, they were training their AI models on that. I can't remember. It was Try Hack Me. You know what sucks is I actually like those guys. Like I don't have like this immediate hatred for them, but you know what? I guess what I'm going to say with as much love as I can possibly say, but screw those guys. And once again, that's basically a bunch of people that I respect and I like Try Hack Me and I like the fact that they were doing that, but come on. Like, what did you really think? Did you think that everyone was going to applaud the fact that you were trying to put them out of a job by using their training data and their certification data? So here's what my take is, and this is my assumption, okay? I believe that this was a choice that was made by a very small number of executives. And I believe the vast majority of people at TryHackMe were not behind this, because I can't see anyone in the industry being like, yeah, that's totally, let's just violate the trust of all of our customers in the TryHackMe universe and just rip it out and then use it to profit by generating an AI model. Because that's what it is. It's theft by any other name. And let's be honest, like, this Aaron Schwartz and some other people, gained access to a newspaper's database, shared it with them, and literally went to prison over that stuff, right? And you have ChatGPT, you have Facebook, and you have all these people that are literally stealing terabytes of data and using it to train their models, and they're becoming billionaires. And that's jackass moves. So I see, but even I am willing to bet that their terms of service, I don't know, maybe it did have that they could use it to train AI models, but it's bad. A group that I used to work with, not that one, a different one, was actually using the stuff that we were doing in calls and stuff that we were doing in customer calls and things like that, recording them and then using that to create a chat bot. To replace us as well. I hate to say it, but that's kind of like my IP. Now, I believe that there's a fundamental difference. Whenever I start teaching this class and I'm teaching it on YouTube, I'm putting it on a public forum, okay? I do believe that I have really little leg to stand on and saying, yeah, you guys can't take that and redo me because it's on a public forum, right? You got to expect that. But when you're doing a certification, that's kind of dog shit. And I'm just going to say, do better. I think somebody said that right here. Jesse said it. And I think that nailed it. And once again, I know there's great people that try hack me and all of that, but yeah, that's got me on a rant right there. All right. What other questions are going to get me in trouble with everybody in the industry? So somebody wanted to see a conversion, see a Testament or Pantera. Oh, Testament for me. I'm sorry. I like the vocals from Testament a lot better than Pantera. I just do. Now, if we're looking at just the music and the raw punch you in the face intensity, Pantera. Absolutely. SOC and potentially cert roles, which languages are more practical to learn and which order do you suggest to learn them? I'd recommend learning Python and then probably stopping. And the reason why is whenever you learn one coding language, okay, whenever you learn one development language and you understand how languages work, how IDEs work, how that all works, then it really makes it a lot easier for you to work with a chatbot like Claude and using Anthropic's tools to be able to use that language to transfer to other languages. One of the things that I think is pretty great is I have developers and they're running things in React and Golang and all these things. And we had to rewrite the cyber deception module in AC Hunter, and they rewrote the cyber deception module in like 4 days, and it took like a month before, and it was all in .NET. Because they had deep skills in one coding language, it was immediately transferable for them to communicate with Claude to develop the output that they needed to be successful. So learning one really good language is key to kind of setting you up to using the AI models that are out there as well. Will they completely automate SOC? Hell no. No. I mean, if you're looking at the attack surface, I'm going to get on the news here at 2:30. And if we're looking at like Axios, NPM, supply chain breaches, SolarWinds, we're seeing the attack surface shift, right? Identity is now the perimeter. It used to be your endpoint, then it was the browser. Now it's your user ID. It's your refresh tokens and Entra ID. It's things and tools like Graph Runner and Scout that come into play for cloud. But you're also seeing the attack against the supply chain. So the attackers are shifting. The other thing that I think is wild that people are not talking about is it's always this asymmetry of conversation based on the side of offense and defense you are on. So if you're talking to offensive pen testers, there's a lot of people that fall into two camps. Either they're like, oh, woe is me, that's it for pen testing. Or there's a group of pen testers like, holy crap, this is really cool. We have all of this really cool stuff that we can do, all these new techniques, all these new capabilities. Yeah, you want to be in that camp. You want to be the excited about technology camp. On the defensive side, same thing. You have people like, I can automate all of this. I can do all this stuff with AI. I can do run books, pull all the relevant data to me whenever I have an alert and it analyze that. And I don't have to do it by hand. Hell yeah. And then you have a bunch of people in the SOC that are like, woe is me, I'm going to be out of a job. Be in the forward leaners, be in the group of people that are trying to push the technology as fast and as hard as you can. And all of this shit that we're talking about in the SOC core skills class applies because you have to understand these core fundamentals before you really can start using AI appropriately to give it proper context. Let me give you an idea. So whenever I talk about context, right? People that don't understand, people that do not understand the people that do not understand AI think that you can go to AI and say, hey, code me an entire pen testing platform. And it's going to try to do its best, right? It's going to try to do its best, but it isn't getting a lot of context. So it's going to be very mediocre, or it's probably not going to be exactly what you want. However, if you can give it more data on specifically what it is you want out of it for multiple different steps from prompt engineering, and you understand the technology at the level that you can ask the right questions, you get much better data out of it. So to give you an idea of context and assumptions, I'm going to tell you a story. There's nothing wonderful or brilliant or deep about this story, but it articulates your problem when communicating with AI without proper context. So the story goes like this. My wife and I love walking through the woods. It's one of my favorite things to do with my wife is just walking through the woods. Hold. My wife and I, when we walk through the woods, we really like to walk through forests near the ocean. Our favorite place to walk near the woods and the ocean is in the Pacific Northwest up around Seattle. All right. So let's talk about context. Whenever I started about my wife and I walking through the woods or the forest, you had multiple different people that had different perspectives of what that was. Was it a forest in winter? Was it a forest in fall? Was it a forest in summer? Was it a carnivorous forest? Was it a deciduous forest? What type of forest was it? I didn't provide context. And in your head, you built a model of what I was talking about, but that model was different for every single one of you. Whenever I said we like to walk next to the ocean, was it a mangrove forest? Was it a palm forest? Was it a pine forest? It wasn't until I gave you the specific location that all of your views of what I was describing collapsed into something that made sense and correlated what I was saying with the context and what you were interpreting it as. But I had to give you more context. So if you're working with AI, and you don't understand the technical fundamentals, you're not going to be able to flush out the context for artificial intelligence to be able to get the data that you need out of it as well. ACE-T. So if you look over in resources and SOC core skills, let's go over to ACE-T. I'm going to share my screen, or Daryl and Kevin, could you all switch over to my screen for the screen share real quick? All right. Waiting for it. They're going to bring it up here in a second. I'm going to resume my screen share. There we go. All right. So we've got this, where is it? ACE-T certification, right? So the ACE-T certification is a 100-question multiple choice exam, and it includes hands-on challenges. So whenever you access the portal, these are the steps that you need to do. And all these instructions are in that doc, right? Step one, complete the multiple choice exam. It's just 100 multiple choice questions. You have 2 hours to complete it. You have to get 75 or higher. By the way, the reason why we created ACE-T is because I hate multiple choice certifications. I absolutely just abhor them. I hate the fact that you have companies out there that charge $800 or $1,000 or more money to do a multiple choice test to say that you're certified. I think that that's dog shit. It's lazy and it's overpriced. So we created this one. I think it's like $25 to do the ACE-T core certification. And for a lot of you, it's just, hopefully we have costs associated with this, and it's not just my cost. After you pass the exam, And this is where this gets really important. After you pass the exam, you will be able to start the second phase. You will be assigned 10 hands-on CTF challenges in the anti-siphon cyber range. You will have to solve at least 5 of them, and you will have to upload 2 write-ups of the challenges. These write-ups will then become publicly accessible for everyone that views your certificate. The point of this is, it isn't just enough to solve these challenges. You have to do a write-up. So if somebody's trying to hire you and say that you're ACE-T certified, they can look at your work output. They can see what quality of work you generate to do that. All right? So that is the ACE-T core certification. That's meant to be a basic level certification for this class and intro to security that'll get you so you can get certified and put it on your resume to help you get jobs. And it's also designed to be affordable for people as well. NIST training, all of this training applies to NIST. In fact, all of our training at the at Anti-Siphon is mapped to the NIST cyber work roles. We do have a Black Friday sale. Megan, I don't know if we still have that link up, but it's literally every single class that we have for $1,500, full access for an entire year on that as well.
We do. I can grab it. The only thing that's no longer offered is the Wild West Hack and Fest ticket. That hasn't been taken off there because obviously it's over. So if people want to register, they can, but that is not included.
You bet. Thank you. What is your opinion that the American federal agencies, CIA, is enabled to access customer data if they request it from any vendor? Would you please provide some insight? Is that something you heard about, experience? Is it a somewhat interesting topic in Germany? Are some thoughts about EU independence from services like Microsoft? Good question. My clearance was at the NSA NRO. That's where I got my clearance, and I was working directly in this. So if you are working in the CIA or any intelligence related area, you're supposed to put out a FISA warrant. Now, when I was there, you would have to fill out a very detailed FISA warrant. It would be reviewed by a FISA judge, and they would say yes or no for you to gain access to data that involved US citizens. Now, that kind of changed. I left, and the stuff that Edward Snowden released kind of showed that some of that had been reduced to automated forms to be able to gain access to US citizen data. So that is a bit of a concern for me. So I can't speak much beyond like 2008 and what I know about that. But I will tell you that there were restrictions whenever I was there around what you could do with a FISA warrant to be able to do that. And also was very much restricted, especially if you're talking intelligence agencies. You usually couldn't trigger a FISA warrant until a citizen was talking outside of the United States to a known person of interest, let's say a possible terrorist or money launderer. That would trigger that. Then we get a FISA warrant to be able to intercept that data. However, if it's inside the United States, that would be something that would go through the process that the FBI does. And that would also require a warrant to be able to gain access to those data sets. Now, I'm saying all of this based on my experience. The stuff that Edward Snowden released showed that some of those restrictions had been reduced as well. Now, when you're talking about data and access and you're looking at GDPR and things of that nature, this gets very interesting whenever you're talking about cloud providers in the United States versus EU. There's always going to be some level of data that has to be identifiable for people. Otherwise, the internet doesn't work. So it's tough, right? But I do like that the EU is very much more forward leaning on this, and they tend to be more on the side of privacy than a lot of other countries out there as well. I'm trying to become a cyber systems operator. I've never done anything in the totality of cyber aside from this. Where should you suggest I start to have a really solid family? You're here. Welcome. Just start hitting our pay what you can training classes. And if you're rushing for time, Sin, we also have the other phases of this class available on YouTube. So you can go and watch those courses as well to get ahead. And your lab environment will work on that as well. Hey, John, why would I register for this class if it's already free now, currently watching you on YouTube? You don't, Flame. You don't have to.
You don't have to register, but if you want a certificate of completion to say that you did register for, or that you did take the class and you need CPE credits for maybe a certification or two, then you need to register, because if you're just watching it on YouTube, we don't know.
Yep, it's up to you. We just want to make sure that we're available to people. We can meet you where you're at. Either A, you're right there and you are, you're just taking what you can get because economic circumstances and you can't afford anything, and that's fine. That's no big deal for us. We're happy to have you, no matter how it is. Need at least 3 prompts for that. Oh man, there's some really pissed off people for try hack me.
Just keep scrolling.
How did Twilight get in here, Megan?
Well, because you were talking about a Pacific Northwest.
Actually, Megan, I was at the town where the books were set. I can't remember. It's in Washington State. God, what's the name of that town? We were actually there 2 weeks ago.
Yeah, that's so funny because you were talking about walking in the woods, and
Yeah,
they walked in the woods, and you're kind of glowing like a vampire right now. So
I am. I'm sparkling in like Bowie in the morning sun. Got to get that vampire money. So it's funny because we were in the Pacific Northwest in those exact woods. I can't remember the name of the town where that was set, right? And my wife has a little bit of a sore ankle, and I was like, hey, do you want to get on my back and I can go running through the woods with you? And she's like, that's stupid. That sounds like one of the dumbest things ever. And you know what? She was right. All right, what other
forks? Somebody put forks.
Forks, that's where it's at. Yep, that's where we were. Stuck on. I say carnivorous, and people are like carnivorous. Yes, the walloping willow. No, I just got to that question. What else? What do we got here? Forks. Team Jacob. What is the joke? Team Jacob was a PR manifestation. What did the guy that played
Jacob was the werewolf.
Yeah, but they said
and
that
Edward was the vampire.
There was no such thing as Team Jacob, as the guy that played Edward said. It was just a PR stunt.
So somebody said if you could go back in time and have the power to short a company tech, what would you remove from the modern world? OSI is protected.
OSI is protected. I would get rid of cell phones. I would get rid of iPhones and touchscreen phones. I would, seriously, if I had anything I would do at all, it would be that. As soon as Steve Jobs came out with the iPhone and the touchscreen and how amazing that was, that like fundamentally changed our relationships to technology, right?
Yeah.
So if you were looking at technology before, you could use your phone as a hotspot, sometimes plug it in, and then you'd have your laptop. There's something fundamentally different to using a notebook computer and having this constantly on and sucking away your entire life at all times. This was a mistake.
Well, I mean, just a cell phone in general. I mean, think about like when we were growing up, if you were at school and you were sick and your parents called and they didn't answer the phone because your parents weren't home. Like right now, we're so accessible.
I agree.
Like all the time.
And for me, I kind of like that accessibility. Like the flip phones, I was okay with, right?
Yeah.
But yeah, and I could see that absolutely. But no, I think that cell technology being at the level that it is, I think that we screwed up. I think that was a mistake. If I could get rid of one thing, it would be that. Another question. I might be at DEF CON. I'm currently all around sysadmin doing both. I'm wondering whether there's a particular talk or village to be on the lookout. I would just go to anything that you can find. I'm a huge fan of like IoT villages and stuff. But that's just me. I think that's pretty cool. So yeah, look at those.
Just network as much as you can.
Network, just hang out. Just
hang out with
be
people.
a person with people. All right, but I've got to get going before my next meeting. Thank you so much, everybody. We will see you tomorrow, and we will continue. We're going to jump straight into Linux. So if you're new to Linux, you have no idea, tomorrow's the day for you. All right, take care, everybody.
All right, everyone. Have a good rest of your day. Hopefully we will see you tomorrow. Please come back and join us for day 2. And the recording will be posted in the resources channel after it's processed. And make sure you come back all days. And because Friday we do play Thursday. Sorry, gosh. It's only a 4-day class, Megan. Thursday we play bingo and it's super fun and you can win the whole Roswell, stop it. You could win the whole on-demand course catalog. It's kind of a big deal. So keep coming back. And people that are joining us via stream, you can still register if you want to. Registration stays open until the end of class. All right, Daryl, it's time to kill it with fire. Have a good night, everyone.